everyone. We're working through an introduction to statistical methods and data analysis by Ott and Longnecker. We are on chapter 12, part 1. We're going to do an example. A survey of information systems managers was used to predict the yearly salary of beginning programmer/analyst in a metropolitan area. Managers specified their standard salary for a beginning programmer/analyst, the number of employees in the firm's information processing staff, the firm's gross profit margin in cents per dollar of sales, and the firm's information processing cost as a percentage of total administrative costs. Let Y equal the salary, X1 equal the number of employees in the firm's information processing staff, X2 equal the profit margin, and X3 equal the IP cost. The coefficients and respective standard errors, t-values, and p-values are given in the table, as you can see here. All right, significance codes are marked with stars, and we get our residual standard error, our multiple R squared, our adjusted R squared, and our overall F statistic with its corresponding p-value. So the first question says, write out the regression line. All right, Y hat equals 25, I'm going to do some rounding, 0.54 plus 0.0039 times X1, the number of employees in the firm's information processing staff, plus 0.0957 X2, the profit margin, plus 0.2163 times IP cost, or X3. Okay. It would have been appropriate to write it this way, or you could have said the expected salary is equal to 25.5378 plus 0.0039 times the number of employees in the firm's information processing staff plus 0.0957 times the profit margin plus 0.2163 times the IP cost. Either of those would have been fine with me. All right, interpret the slope for the profit margin. All right, let's first identify the estimated slope. So profit margin was X2, so beta hat 2 was equal to 0.0957. All right, so, and profit margin is measured in cents per dollar of sales. So a 1 cent per dollar of sales increase in X, right, in the profit margin is associated with a 0.0957, right? But salary was measured in thousands of dollars, right? So with a $957 increase in the yearly salary of the programmer/analyst. All right, great. Okay. Suppose that the manager reported the following. They have someone who has a salary of 29.5, so they're making $29,500. Okay, the number of employees in the firm's information processing staff was 58. The profit margin was 19.4 and the IP cost was 10.14. Let's get the value of the residual for this manager. Okay, so first of all, we know their YI is 29.5, but now we need their YI hat, right? Their YI hat is 25.5378, right? Plus 0.0039 times the number of employees, 58, plus 0.0957 times 19.4, plus 0.2163 times 10.14. Once you calculate that out, there's your observed and your predicted. So you do the residual for that person. The residual for the ith person is equal to 29.5 minus whatever this whole big piece equals. We're going to fill that in, and then we'll get the calculated residual. All right, you can either do that on your calculator or in R to figure out what that piece is, and that will give you the residual. Okay, below are the diagnostic plots associated with the model. Okay, what do the plots indicate about your model? All right, when I look at these plots, and I'm going to make it slightly bigger here, right? So the residuals versus fitted values, right? They might have some curvature in them, right? We're either going to say that they're slightly random, but what concerns me over here is that you just have a few data points that are off on their own. Looking at all these plots, the scale location plot, this red line being under 1, usually you'd want to see this at 1. So we have some curvature in this as well. So we might need to do some sort of transformation. Our normal QQ plot looks okay. Those points lie pretty close to a line. But here, residuals versus leverage, we see that we have a couple points with a very, very high leverage, which might be affecting our prediction model. So those are the pieces that we should consider when we look at this. All right. So the only thing left to do is to calculate the actual YI hats, and you can do that however you see, but I'm going to just use R to do this because that's what's close for me. You can use your calculator. And let me see. I think I just have you guys shared on my notebook, but calculate it along with me. 25.5378 plus 0.0039 times 58, right? Plus 0.0957 times 19.4 plus 0.2163 times 10.14. Paste this in for you. We end up getting 29.8139. And so the residual itself, right, we're going to take 29.5 and we're going to subtract that predicted value. And what we get at the end of the day is negative 0.3139. All right. So make sure that you can get that either using R or a calculator that you can get not only the residual, but also the prediction for this particular person. All right, I hope you learned something today, and I'll see you next time.